$ruby sample underscore ruby underscore file. .rb. This string is self-referential. Note that the output of sample underscore ruby underscore file. .rb looks different from the same code entered into herb. Here, there's no trace of the addition and the square root operations, because they produce no output. Installing the software Ruby comes pre-installed on Mac OS X and most Linux installations. Windows doesn't come with Ruby, but it's easy to get it with the one-click installer. If you're on a Unix/Linux system and you don't have Ruby installed, or you want to upgrade, your distribution's package system may make a Ruby package available. On Debian GNU/Linux, it's available as the package Ruby-version, for instance, Ruby 1.8 or Ruby 1.9. Red Hat Linux calls it Ruby, so does the Darwin Part system on Mac OS X. If all else fails, download the Ruby source code and compile it yourself. You can get the Ruby source code through FTP or HTTP by visiting HTTP URL. Many of the recipes in this book require that you install third-party libraries in the form of Ruby gems. In general, we prefer standalone solutions, using only the Ruby standard library, to solutions that use gems, and gem-based solutions to ones that require other kinds of third-party software. If you're not familiar with gems, consult Chapter 20 as needed. With Ruby gems built in, it's easy to install many other pieces of Ruby code. When a recipe says something like Ruby on Rails is available as the Rails gem, you can issue the following command from the command line, again, as the super user. $gem install Rails. The Ruby gems library will download the Rails gem and any other gems on which it depends and automatically install them. You should then be able to run the code in the recipe exactly as it appears. The three most useful gems for new Ruby installations are Rails, if you intend to create Rails applications, and the two gems provided by the Ruby Facets project, facets_core and facets_more. The Facets core library extends the classes of the Ruby standard library with generally useful methods. The Facets more library adds entirely new classes and modules. The Ruby Facets homepage has a complete reference. Some Ruby libraries, especially older ones, are not packaged as gems. In most cases, you can download a tarball or zip file from the RA and install it with the technique described in Recipe 20.8. 24 Preface. Platform differences, version differences, and other headaches except where noted, the recipes describe cross-platform concepts, and the code itself should run the same way on Windows, Linux, and Mac OS X. Most of the platform differences and platform-specific recipes show up in the final chapters, chapters 22, 23, and 25, but see the introduction to Chapter 7 for a note about Windows file names. We wrote and tested the recipes using Ruby version 1.8.4 and Rails version 1.1.2, the latest stable versions as of the time of writing. In a couple of places we mention code changes you should make if you're running Ruby 1.9, the latest unstable version as of the time of writing, or 2.0. Despite our best efforts, this book may contain unflagged platform-specific code, not to mention plain old bugs. We apologize for these in advance of their discovery. If you have problems with a recipe, check out the errata for this book. See the section Comments and Questions on page 27 below. In several recipes in this book, we modify standard Ruby classes like array to add new methods. See, for instance, Recipe 2.10, which defines a new method called string #S_first_letter. These methods are then available to every instance of that class in your program. This is a fairly common technique in Ruby. Both Rails and the aforementioned Facets core library do it. It's somewhat controversial, though, and it can cause problems. See Recipe 9.4 for an in-depth discussion. So we felt we should mention it here in the preface, even though it might be too technical for people who are new to Ruby. If you don't want to modify the standard classes, you can put the methods we daemon as straight into a subclass, or define them in the kernel namespace. That is, define $first_letter_string instead of reopening string and defining $first_letter inside it. Other resources if you need to learn Ruby, the standard reference is Programming Ruby. The Pragmatic Programmer's Guide by Dave Thomas, Chad Fowler, and Andy Hunt, Pragmatic Programmers. The first edition is available online in HTML format, but it's out of date. The second edition is much better and is available as a printed book or as PDF. It's a much better idea to buy the second edition. For Rails, the standard book is Agile Web Development with Rails by Dave Thomas, David Hansen, Leon Breed, and Mike Clark, Pragmatic Programmers. There are Preface 25. Also 2 books like this one that focus exclusively on Rails. Rails Cookbook by Rob Orsini, O'Reilly, and Rails Recipes by Chad Fowler, Pragmatic Programmers. Many people come to Ruby already knowing one or more programming languages. You might find it frustrating to learn Ruby with a big book that thinks it has to teach you programming and Ruby. For such people, we recommend Ruby User's Guide by Ruby creator Yukihiro Matsumoto. It's a short read, and it focuses on what makes Ruby different from other programming languages. Its terminology is a little out of date, and it presents its code samples through the obsolete eval.rb program. Use ERB instead, but it's the best short introduction we know of. If you are a Java programmer who wants to learn Ruby, check out the blog entry, Coming to Ruby from Java by Francis Huang. C++ programmers will also benefit from much of what's in here. Finally, Ruby's built-in modules, classes, and methods come with excellent document iTTION, much of it originally written for programming Ruby. You can read this documentation online at http URL and http URL // You can also look it up on your own Ruby installation by using the re-command. Pass in the name of a class or method, and re will give you the corresponding documentation. Here are a few examples. $rearray hashtag a class $rearray new hashtag a class method $rearray hashtag compact hashtag an instance method conventions used in this book. The following typographical conventions are used in this book. Plain text indicates menu titles, menu options, menu buttons, and keyboard accelerators, such as Alt and Control. Italic indicates new terms, URLs, email addresses, and Unix utilities. Constant width indicates commands, options, switches, variables, attributes, keys, functions, types, classes, namespaces, methods, modules, properties, parameters, values, objects, events, event handlers, XML tags, HTML tags, macros, programs, Libra iRise, file names, path names, directories, the contents of files, or the output from commands. Constant width bold shows commands or other text that should be typed literally by the user. Constant width italic shows text that should be replaced with user-supplied values. Using code examples, this book is here to help you get your job done. In general, you may use the code in this book in your programs and documentation. You do not need to contact us for permission unless you're reproducing a significant portion of the code. For example, writing a program that uses several chunks of code from this book does not require permission. Selling or distributing a CD-ROM of examples from O'Reilly Books does require permission. Answering a question by citing this book and quoting example code does not require permission. Incorporating a significant amount of example code from this book into your product's documentation does require permission. We appreciate, but do not require, attribution. An attribution usually includes the title, author, publisher, and ISBN. For example, Ruby Cookbook, 2nd edition, by Lucas Carlson and Leonard Richardson. Copyright 2015 Lucas Carlson and Leonard Richardson, 978-1-449-37371-9. If you feel your use of code examples falls outside fair use or the permission given above, feel free to contact us at permissions@o'reilly.com. Comments and questions. Please address comments and questions concerning this book to the publisher, O'Reilly Media Incorporated, 1005 Gravenstein Highway, North Sebastopol, California, 954-72-800-998-9938, in the United States or Canada. 707-829-0515, international or local. 707-829-0104, fax. We have a web page for this book where we list errata, examples, and any additional information. You can access this page at http URL. To comment or ask technical questions about this book, Send email to booksitines@o'reilly.com. For more information about our books, conferences, resource centers, and the O'Reilly Network, see our website at http URL. Acknowledgements. First, we'd like to thank our editor, Michael Lukides, for his help and for acquiescing to our use of his name and recipe code samples, even when we turned him into a talk, ing frog. The production editor, Colleen Gorman, was also very helpful. This book would have taken longer to write and been less interesting without our contributing authors, who, collectively, wrote over 60 of these recipes. The role of names includes Steve Arniel, Ben Bleething, Antonio Congiano, Mauro Ciccio, More Ais Kodik, Thomas Enabo, Pat Eiler, Bill Froelich, Rod Gaither, Ben Giddings, Michael Granger, James Edward Gray II, Stephen Lang, Kevin Marshall, Matthew Palmer Chaitin Patil, Ayland A.P. Riziart, Garrett Rooney, John Mason Shackelford, Phil Thompson, and John Wells. They saved us time by lending their knowledge of various Ruby topics, and they enriched the book with their ideas. This book would be of appallingly low quality were it not for our technical reviewers, who spotted dozens of bugs, platform-specific problems, and conceptual errors. John N. Allegra, Dave Burt, Bill Dolliner, Simon Edwardson, Shane Emmons, Edward Falk, New, Dan Fitzpatrick, Bill Ginden, Stephen Hildry, Metter Inga, Eric Jacoboni, Julian I., Camel, Randy Kramer, Alex Ladon, Stephen Lumos, Keith Rosenblatt, Gene Tanney, and Irv Rajmohan. Finally, thanks to the programmers and writers of the Ruby community, from the celebrities like Yukihiro Matsumoto, Dave Thomas, Chad Fowler, and Y to the hundreds of unsung heroes whose work went into the libraries we demonstrate throughout the book, and whose skill and patience bring more people into the Ruby community all the time. Chapter 1 Ruby 2.1 When the first edition of Ruby Cookbook was published in 2006, Ruby 1.8.4 was the state-of-the-art and Rails had just reached 1.0. 8 years and more than 100 stable releases later, the latest version is now Ruby 2.1.1 and Rails has just reached 4.1.0. Over the last 8 years, a lot has changed, both big and small. A bytecode interpreter replaced the old Ruby MRI. Ruby gems and rake became part of the standard library. SOAP and curses have moved out of the standard library into Ruby gems. New syntax primitives have been added for hashes, procs, and more. New methods like object hashtag tap and string hashtag prepend have been added. New classes like basic object, fiber, and tracepoint have been added. The MD5 standard library was renamed Digest, MD5. And much more. The end result is a cleaner language that runs faster and more efficiently than ever before. For example, a simple Rails application is 167 to 200% faster in Ruby 2.1 than 1.8. For all that has changed, there is thankfully very little that has been broken in terms of backward compatibility. The vast majority of code written for Ruby 1.8 will work in Ruby 2.1 without any modifications. However, and somewhat obviously, if you write code for Ruby 2.1, it will likely not work in Ruby 1.8 with some of the syntax changes introduced. In between Ruby 1.8 and 2.1 were two other major releases, 1.9 and 2.0. In this chapter, we will group all the changes from versions 1.9 through 2.1 together instead of one, pointing out the specific .release in which a feature was added or modified. For example, the YRV bytecode interpreter was added only in Ruby 1.9.4, but we will talk about it as just one of the many differences between Ruby 1.8 and 2.1. 1.1 What's different between Ruby 1.8 and 2.1? Problem You want to know the major differences between Ruby 1.8 and 2.1. Solution Table 1 shows the major changes between Ruby 1.8 and 2.1. Table 1 Major changes by type between Ruby 1.8 and 2.1 type about note new syntax the operator can replace lambda for brevity. New syntax array you can use %I, foo bar baz, to specify foo bar baz for brevity. New syntax def you can define methods like def foo x 1 puts x and new class basic object new root in class hierarchy. New syntax hash you can use a 1, b, 2, which is like a equals 1, b equals 2 for brevity. New syntax are you can apply the or suffix to numbers to specify rationals like 1.2r. New class GC. Profiler profiles the garbage collector. New class encoding represents a character encoding. New class enumerator. Lazy delays running enumerations until absolutely necessary. New class fiber lightweight processes. New class gem Ruby gems. New class random pseudo-random number generator. 2 Chapter 1 Ruby 2.1. Type about note new class Ruby VM, the Ruby interpreter. New class socket. IFADDR interface address class. New class tracepoint dtrace-like inspection class. New method array _convert tries to convert obj into an array. New method array #rotate creates a new array by rotating the existing array. New method array #keep _if deletes every element where the block evaluates to false. New method array #sample chooses a random element. New method array #repeated _ permutation all repeated permutations. New method array #repeated _ combination all repeated combinations. New method to _h ubiquitous hash conversion. New method #default _proc equals you can now set the default proc after initialization. New method #key and inverted hash lookup. New method #keep _ if deletes every key value pair where the block evaluates to false. New method #association searches through the hash comparing obj with the key using ==. New method #rassix searches through the hash comparing obj with the value using ==. New method #flatten a one-dimensional flattening of this hash. New method compare _ identity compares hashes by their identity. New method enumerable to _h ubiquitous hash conversion. New method enumerable flat _map creates array with the concatenated results of running block once for every element in enum. New method enumerable each _ entry calls block once for each element in self, passing that element as a parameter, converting multiple values from yield to an array. 1.1 What's different between Ruby 1.8 and 2.1? 3. Type about note new method enumerable each _ object iterates the given block for each element with an arbitrary object and returns the initially given object. New method enumerable chunk enumerates over the items, chunking them together based on the return value of the block. New method enumerable slice _ before creates an enumerator for each chunked element. New method enumerable lazy delays running enumerations until absolutely necessary. New method exception cause keeps track of the root cause of raised errors. New method gc.stat inspects the garbage collector. New method kernel #dir director name of file. New method kernel #cali called name of the current method as a symbol. New method kernel #caller _ locations array of backtrace location objects. New method kernel spawns similar to kernel.system, but doesn't wait for the command to finish. New method kernel require _ relative tries to load the library named string relative to the requiring file's path. New method kernel hash ubiquitous hash instantiator. New method kernel rational ubiquitous rational instantiator. New method kernel complex ubiquitous complex instantiator. New method module class _ variable _ get gets class variable. New method module class _ variable _ set sets class variable. New method module remove _ class _ variable removes class variable. New method module public _ constant makes a list of existing constants public. New method module private _ constant makes a list of existing constants private. New method module singleton _ class. Is it a singleton? New method module prepend an alternative to module include that appends, overwrites, class methods. New method module public _ instance _ method public instance methods. New method module refine allows you to refine an existing class. New method module hashtag using allows you to apply monkey patches in a scoped way. New method IO hashtag wait under writable waits until a file becomes writable. New method object hashtag returns true if two objects do not match using the equals method. New method object hashtag singleton underscore class returns the singleton class of obj. New method object hashtag untrust marks obj as untrusted. New method object hashtag untrusted returns true if the object is untrusted. New method object hashtag trust removes the untrusted mark from obj. New method object hashtag remove underscore instance underscore variable removes the named instance variable from obj. New method object hashtag public underscore send unlike object hashtag send. This calls public methods only. New method object hashtag public underscore method similar to method. This searches public method only. New method object hashtag singleton underscore methods lists one-off methods. New method object hashtag define underscore singleton underscore method creates a one-off method. New method object hashtag tap taps into a method chain to perform operations on intermediate results. New method range hashtag search binary search available in arrays. New method range hashtag cover is obj between the begin and end of the range. New method socket.getIfAddrs accesses network interfaces. New method string hashtag ASCII underscore only returns true for a string that has only ASCII characters. New method string hashtag clear makes a string empty. String hashtag chr a one-character string at the beginning of the string. New method string hashtag encode encodes a string with an encoding. New method string hashtag getByte returns a byte as an integer. New method string hashtag setByte modifies a byte as integer. New method string hashtag byteslice a substring of 1 byte at a position. New method string hashtag scrub removes garbage bytes from strings. New method string hashtag code points integer ordinals of the characters in str. New method string hashtag prepend a given string. New method string hashtag ord returns the integer ordinal of a one-character string. New method string hashtag each underscore code point enumerates the integerized values of the string. New method string hashtag encoding an encoding object that represents the encoding of the string. New method string hashtag force underscore encoding forces an encoding. New method string hashtag be a copied string whose encoding is ASCII 8-bit. New method string hashtag valid underscore encoding true for a string that is encoded correctly. New method string hashtag to underscore r returns rational number. New method string hashtag to underscore c returns complex number. Removed method array hashtag items removed. Removed method array hashtag indexes removed in favor of array hashtag values underscore at. Removed method array hashtag indices removed in favor of array hashtag values underscore at. Removed method hashtag indexes removed in favor of hashtag select. Removed method hashtag indices removed in favor of hashtag select. Removed method object hashtag ID removed in favor of object hashtag object underscore ID. Removed method object hashtag type removed in favor of object hashtag class. Removed method object hashtag to underscore a removed in favor of kernel hashtag array. Removed method string hashtag each removed in favor of string hashtag each underscore byte and string hashtag each underscore char. Removed method enumerable hashtag enum underscore slice removed in favor of enumerable hashtag each underscore slice. Removed method enumerable hashtag enum underscore cons removed in favor of enumerable hashtag each underscore cons. Removed method enumerable hashtag enum index removed in favor of enumerably hashtag each underscore index. New standard library rake no longer an external library. New standard library JSON no longer an external library. New standard library psych a YAML parser and emitter that leverages libyaml. New standard library secure random pseudo-secure random number generator. New standard library IO/console add console capabilities to IO. New standard library IO/nonblock add nonblock capabilities to IO. New standard library CMath trigonometric and transcendental functions for complex numbers. New standard library debug provides debugger and breakpoints. New standard library E2 map exceptions to messages map. New standard library fiddle a libfi wrapper. New standard library minutest drop-in replacement for test unit. New standard library obj-space object allocation tracing profiling tool. New standard library prime the set of all prime numbers. New standard library Ripper parses your Ruby code into a symbolic expression tree. New standard library shellwords manipulates strings according to the word parsing rules of Bash. Move to core Ruby gems no longer an external library and no need to require Ruby gems. Move to core complex now part of core. No need to require. Move to core enumerator now part of core. No need to require. Move to core rational now part of core. No need to require. Move to core thread now part of core. No need to require. Move to Ruby gems SOAP you can use gem install SOAP. Move to Ruby gems curses you can use gem install curses. Move to Ruby gems icon view can use gem install icon. Move to Ruby gems parsedate you can use gem install rubisil parsedate. Move to Ruby gems Rinda you can use gem install rubisil Rinda. Removed library finalize replaced by obj-space. Removed library code UTF-8 support is now default. $code is not necessary. Removed library WSDL no longer a standard library. Removed library ftools merged into faloodles. Removed library generator no longer a standard library. Removed library important no longer a standard library. Removed library mailread no longer a standard library. Removed library ping no longer a standard library. Removed library runit no longer a standard library. Removed library toolclib no longer a standard library. Removed library Win32 API no longer a standard library. Removed library XSD no longer a standard library. 1.2 YRV, yet another Ruby VM, bytecode interpreter problem. You want to understand more about the Ruby interpreter changes between Ruby 1.8 and 2.1. Solution since Ruby started in 1995, it originally used the MRI, Matz's Ruby interpreter, to interpret Ruby code. Written in C, the MRI, also known as CRuby, was the de facto reference implementation of the Ruby spec until Ruby 1.9.0 was released in 2007. With Ruby 1.9.0, the interpreter was changed from MRI to YRV, yet another Ruby VM. One of the biggest differences between MRI and YRV was the introduction of a bytecode interpreter. With any programming language, the first step to running your 1.2 YRV, yet another Ruby VM, bytecode interpreter 9. Code is to tokenize and parse its syntax. The MRI would mix parsing syntax with executing your code, which ended up being prone to memory leaks and slow execution times. The YRV interpreter separates parsing from the running of your code. The bytecode interpreter takes the syntax tree and passes it to a virtual machine EMUI later that knows how to translate the bytecode into machine code. The emulator is tuned and optimized for the underlying hardware and knows how to translate instructions to PowerPC or x86 instructions. The result in more efficient execution, less memory usage, and a faster language. Discussion to understand bytecode interpreters better, let's examine a simple Ruby syntax tree, also known as S-expressions. Require Ripper. Ripper.sexp 1 + 1. Hashtag equals program binary at int 1 1 0 plus at int 1 1 2. If you have any familiarity with Lisp, you may notice some similarities between a syntax tree and any Lisp dialect. For example, let's replace the brackets with parentheses and see if the code looks any more familiar. Program binary int 1 1 0 plus int 1 1 2. The reason that S-expressions look like Lisp is because essentially Lisp is a program, Ming language built directly with S-expressions. The YRV Ruby VM takes these S-expressions and turns them into bytecode. To see what Ruby bytecode looks like, you can use the Ruby VM class. Require pp. pp Ruby VM. Instruction sequence.compile 1 + 1. To underscore a hashtag. YARV instruction sequence / simple data format. Number 2, number 0, number 1, hashtag. arg_size = 0. Local_size = 1. stack underscore max equals 2, hashtag, compiled, hashtag nil, number 1, hashtag, top, hashtag, number 0, hashtag, 1, hashtag, trace, 1, hashtag, put object underscore opeth underscore t2 fix underscore, hashtag, put object underscore opeth underscore t2 fix underscore 1 underscore c underscore, hashtag, opt underscore plus, mid equals plus, flag equals 256, org underscore gc equals 1, blockter equals nil, hashtag, leave. Bytecode is not nearly as easy to read as S expressions because the bytecode is the actual instructions sent to the VM, which turn into processor instructions. The YRV bytecode interpreter is not the only interpreter available to Ruby develop AIRs. There is JRuby, Rubinius, Maglev, MacRuby, IronRuby, and Ruby Enterprise EDI Tyan, aka RE. Each one is built for a different purpose. For example, JRuby takes pure Ruby syntax and compiles it into Java bytecode instead of YRV bytecode. This allows you to run nearly any Ruby code on any machine running Java. See also the YRV homepage, the JRuby homepage, how Ruby executes your code. The Ruby VM documentation 1.3 syntax changes problem. You want to know the syntax changes between Ruby 1.8 and 2.1. Solution: there were 3 major and 2 minor syntax additions to Ruby between 1.8 and 2.1. The 3 major additions were defining hashes, defining methods, and defining procs. The 2 minor additions were in arrays of symbols and defining rationals. The most obvious syntax addition is for defining hashes. Here is the new way you can do it. Old underscore way equals foo equals bar 1 equals 1 new underscore way equals foo bar 1. You can also apply the same hash syntax when calling methods that take hashes. 1.3 syntax changes 11. Def some underscore method hash equals hashtag do stuff and some underscore method foo equals bar some underscore method foo bar. You can visually see how this can save you 25% of your keystrokes. Fewer keystrokes leads to fewer typos and bugs. Therefore, this new way of specifying hashes is being quickly adopted, and you will see it throughout this book. The old way still works and is not deprecated, but the new way will save you a lot of time over your career with Ruby. This new syntax for defining hashes has also inspired new keyword arguments for method definitions. Hashtag old def old underscore way options equals return options foo and hashtag equals nil old underscore way foo equals bar hashtag equals bar old underscore way hashtag equals nil hashtag new unnamed keyword arguments def new underscore way asterisk options return options foo and hashtag equals new underscore way foo bar hashtag equals bar new underscore way hashtag equals nil hashtag new named keyword arguments def new underscore way foo return foo and hashtag equals new underscore way foo bar hashtag equals bar new underscore way hashtag argument error missing keyword foo. It is interesting to note that def now returns the symbolic name of the method instead of nil. This allows you to string together private and public calls when defining your classes. Class foo private def baz return yay in def bar baz end foo.new.baz hashtag no method error private method bar called for hashtag foo 0x7f6b4ab98 foo.new.bar hashtag equals yay. The last big syntax addition is a new way to define procs. Old underscore way equals proc.new a b plus b old underscore way dot call 1 2 hashtag equals 3 new underscore way equals dash a plus b new underscore way dot call 1 2 hashtag equals 3. This is not only shorter to implement, fewer characters, but it is also consistent with the def method of listing arguments, i.e., it uses parentheses instead of pipes. The first smaller addition to Ruby syntax is specifying arrays of symbols. Old underscore way equals foo bar baz new underscore way equals %I foo bar baz. The second smaller addition to Ruby syntax is a shortcut for defining rational numbers. Old underscore way equals rational, 6, 5. New underscore way equals 1.2 are all of the syntax additions share the same goal, brevity in keystrokes. See also Recipe 1.4, Keyword Arguments. 1.4 Keyword Arguments problem. You want to know how to specify keyword arguments when defining a method. Solution. As of Ruby 2.0, you can define Ruby methods in new ways thanks to the idea of keyword arguments. Here is an example of the most complicated method definition you can possibly do now that has every permutation in it. Def foo a b equals b underscore default asterisk c d e underscore default f and g. Hashtag do stuff and a. Required positional argument, B. Optional positional argument with a default value, C. Splat positional arguments that lack default values, D. Declared keyword argument, E. Declared keyword argument with a default value, F. Double splat keyword arguments that lack default values, G. Block argument discussion. In Ruby 2.1, hashes were upgraded in many ways. For example, the old trick of using def foo bar equals to accept keyword arguments was made into a first-class citizen with the double splat asterisk asterisk syntax. Another way in which hashes were improved was that they preserved their internal order. In Ruby 1.8, the order in which you inserted items into a hash would have no correlation to the order in which they were stored, and when you iterated over a hash, the results could appear totally random. Now hashes preserve the order of insertion, which is clearly useful when you are using them for keyword arguments in method definitions. The new keyword arguments are a great way to save time while coding. Even a few keystrokes per method can add up quickly. 1.5 Performance enhancements problem. You want to know in which areas there are significant performance enhancements in Ruby 2.1 over Ruby 1.8. Solution. There are few places that haven't been internally improved over the last 8 years. However, we will touch on a few major areas of enhancements. The biggest performance enhancements came from the new YRV interpreter, which was discussed in Recipe 1.2. One of the other large performance-enhancing features of Ruby has been the addition of the lazy method to many basic classes, like array and hash, through the enumerator class. Array equals .lazy.map x 10 select x greater than 10 hashtag equals hashtag enumerator. Lazy hashtag no calculations are performed until a method is called to the array object arrayed to underscore a hashtag equals 20, 30 for small arrays like this. The benefit is not clear. However, as you deal with large data and start chaining multiple enumeration methods together, the use of lazy evaluation prevents you from using unnecessary amounts of memory in temporary variables. Here is an example. Def search underscore file underscore name, term. File.open, file underscore name, do file.each.flat underscore map, and split.grep, term. And in the flat underscore map implementation internally uses lazy enumeration automatically. This means that you are going to iterate over the array only once, instead of twice as you might expect since you run two chained enumeration methods. Another area where lazy evaluation has had a dramatic effect is in increasing performance with the Ruby garbage collector, since fewer objects are created to clean up in the first place. A lot more has also changed in GC between Ruby 1.8 and 2.1, including a new algorithm for garbage collection called bitmap marking. The new algorithm implements a lazy sweep, which dramatically reduces overall memory consumption by all Ruby processes. 1.5 Performance enhancements 15. Another area of improvement is in the require method and file and pathname classes. They were refactored, which helps considerably for the initial loading times to start complicated frameworks like Rails. One example of the refactoring was that Ruby 1.8 rechecked the $load underscore path to make sure it is all expanded on every require. This change led to a 35% reduction in initial loading time for a simple Rails app. Stack tracing performance has improved up to 100 times between Ruby 1.8 and 2.1 by allowing you to limit the number of frames requested. The test/unit library was updated to be able to run in parallel, which speeds up unit testing. There have been many more areas of performance improvements, But these contribution UDA most to the nearly 2 times better performance of Ruby 2.1 over Ruby 1.8. See also, read more about YRV in Recipe 1.2. Read more about the new GC algorithm at http URL. Watch a presentation about the Ruby 2.1 GC at http URL. 1.6 refinements problem. You want to monkey patch some code, but do not want your monkey patches to affect other code. Solution: as of Ruby 2.0, you can use the refine and using methods to monkey patch safely within a given context. Here is an example. Module my monkey patches refine string do def length 30 and end class test my monkey using my monkey patches def string underscore length string dot length end string equals foobar string dot length hashtag equals 6 test my monkey dot new dot string underscore length string hashtag equals 30 string dot length hashtag equals 6. Notice that the entire scope of your monkey patching stays within your class. Discussion refinements were an experimental feature until Ruby 2.1, but are now mainstream. The ability to dynamically add and modify functionality of classes at any time is both powerful and dangerous. If you don't like the way something works in Ruby, you can always monkey patch it. However, the dangerous part is the side effects that you do not anticipate. In the example within this recipe, you can clearly see that changing the way string hashtag length works to be static can be a bad idea. However, when it is scoped to a special module to encapsulate the refinement, the potential damage is strictly limited. 1.7 Debugging with dtrace and tracepoint problem. You want to debug your Ruby app in real time. Solution: Ruby 2.1 gives you 2 new and powerful ways to debug your Ruby application: dtrace and tracepoint. With dtrace, you use the D language for making queries about a running process. Here is the basic syntax for the D language. Probe taste action. A probe runs the test, and if it passes, runs the action. A probe looks like this: provider, module, function, name. 1.7 Debugging with dtrace and tracepoint. 17. Modules and functions are optional. There are a number of different probe names available within Ruby, but for this example, we will just use the method entry probe. $sudo dtrace q in Ruby *::, method entry \printf %s\n copy inster arg0 c rake environment rake aborted no rake file found looking for rakefile rakefile.rb rakefile.rb. See full trace by running task with trace rbconfig 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 rbconfig. $sudo dtrace q in Ruby *::, method entry \at copy inster arg0 copy inster arg1 equals count c rake environment rake aborted no rake file found looking for rakefile rakefile.rb rakefile.rb. See full trace by running task with trace file utils commands 1 gem clear underscore paths 1 gem default underscore path 1 gem detect underscore gem deps 1 gem find underscore home 1 gem marshal underscore version 1. Dtrace is very powerful, but you need to learn the D language to use it effectively. Alternatively, you can use tracepoint, which is built into Ruby 2.1 as part of the core library. Here is an example of how to use tracepoint. Trace equals tracepoint.new raise. Do t puts t.inspect and trace.enable require doesn't underscore exit. Hashtag equals hashtag tracepoint. Raise at /kernel underscore acquire.rb. 55 hashtag equals hashtag tracepoint. Raise at /kernel underscore acquire.rb. 141 hashtag equals hashtag tracepoint. Raise at /workspace.rb. 86 hashtag equals loaderer. Cannot load such file. Doesn't underscore exit. Discussion dtrace is a dynamic tracing framework created by Sun originally to debug both kernel and app code in real time. It is a very sophisticated and flexible tool, but the learning curve is steep because you have to become familiar with a new system. Tracepoint is part of core Ruby and available in every Ruby 2.1 environment. Its wide availability combined with the fact that it is written in Ruby make it an easy way for any Ruby developer to debug his or her application. If you want to debug your application such that any raised error will dump you into an interactive Ruby environment automatically, you can combine TracePoint with the debug library by adding this simple code to your app. Hashtag fun_with_debug.rb trace equals tracepoint.new_raise do t require debug. In trace.enable require doesn't_exit. And then you can see the code in action by just running it. $Ruby fun_with_debug.rb debug.rb Emacs support available. /kernel_acquire.rb 57 Ruby gems_activation_monitor enter RDB 1. See also the Ruby dtrace probe names, the dtrace Wikipedia, recipe 16.23, using breakpoint in your web application. Recipe 19.10, using debug to inspect and change the state of your application. 1.8 module prepending problem, you want to allow modifications to class methods while retaining setup and teardown logic for those methods. For example, 1.8 module prepending 19. Module myHelper_def save puts before, super puts after. End class myBadClass include myHelper_def save puts myCode. End myBadClass.new.save hashtag equals myCode. Notice that you were hoping that the before and after text showed up. Solution Ruby 2.1 has a new alternative to include called prepend. Module myHelper_def save puts before, super puts after. End class myGoodClass, prepend myHelper_def save puts myCode. End myGoodClass.new.save hashtag equals, before hashtag equals, myCode hashtag equals. After discussion, the way that prepend works is pretty simple when you inspect the class hierarchy. Def parents, obj. Obj.superclass. Parents, obj.superclass. Obj.reverse. End parents, myGoodClass. Hashtag equals, class, object, basic object, module, parents, myBadClass. Hashtag equals, myBadClass, basic object, prepend puts the myHelper module at the top of the class hierarchy, before the define I tie-ins in the class itself. Include puts the myHelper at the very bottom of the class hierarchy, so it is overwritten when the class is defined. See also, recipe 11.1, finding an object's class and superclass. 1.9 New methods problem. You want to know about some of the most useful new methods in Ruby 2.1 since Ruby 1.8. Solution with over 70 new methods since Ruby 1.8. It can be hard to figure out which ones merit particular attention. This chapter has already covered some good ones like enumerable hashtag lazy, module hashtag refine, and module hashtag using. However, there are a few more examples of some useful methods you may not have used yet. People who love log n, array searching will really enjoy range hashtag search. Array equals 0, 4, 7, 10, 12, 0, array.size. Search array I equals 4 hashtag equals 1, 0, array.size. Search array I equals 6 hashtag equals 2, 0, array.size. Search array I equals 8 hashtag equals 3, 0, array.size. Search array I greater than or equal to 100 hashtag equals nil. The exception hashtag cause method keeps track of the root cause of your errors. This is very handy when your rescue code has a bug in it. In Ruby 1.8, the following code would have raised a method doesn't exist error. Begin require does_exist. Rescue nil. Some method and hashtag loader cannot load such file. Does_exist 1.9 New methods 21. Gaining insight into the garbage collector is one of the nice capabilities Ruby 2.1 provides. Require pp. ppgc.stat hashtag count equals 5 hashtag heap_used equals 138 hashtag heap_length equals 138 hashtag heap_increment equals 0 hashtag heap_number equals 28500 hashtag heap_number equals 42165 hashtag heap_final_number equals 0 hashtag total underscore allocated underscore object equals 105777. Hashtag total underscore freed underscore object equals 77277. One little helper method that is handy is kernel hashtag dir instead of just kernel hashtag file. Puts underscore underscore dir underscore underscore hashtag slash home slash user slash ruby underscore app slash another little helper that is useful is kernel hashtag require underscore relative, which allows you to require a local Ruby file. Hashtag old way require file dot expand underscore path file dot join file dot dir name underscore underscore file underscore underscore lib mylib. Hashtag new way with underscore underscore dir underscore underscore require file dot expand underscore path file dot join underscore underscore dir underscore underscore lib mylib. Hashtag new way with require underscore relative file dot join lib mylib. For sysadmins who need network information, socket.getafadders is your new best friend. Require socket. Require pp. pp socket.getafadders hashtag equals hashtag socket. If fader low up, look back, running 0x10,000 hashtag packet. Protocol equals 0 low hey type equals 772 host water equals 00 colon 00 colon 00 colon 00 colon 00 colon 00. Hashtag socket. If fader low up, look back, running 0x10,000 hashtag 127.0.0.1 netmask equals 255.0.0.0. Hashtag. An interesting new method is enumerable hashtag chunk, which will create subarrays based on repeated information. The next example shows how to use enumerable hashtag chunk to separate the vowels from the consonants in a sentence. The chunk method is lazy, so no interstitial objects are created in the process of iteration. The quick brown fox each underscore char chunk do letter %w at eiou at include letter, vowel, consonant, and each do type letters puts hashtag type hashtag letters join end hashtag consonant th hashtag vowel e hashtag consonant q hashtag vowel ui hashtag consonant ckbr hashtag vowel o hashtag consonant w and f sharp vowel o hashtag consonant x, and finally a simple string method string hashtag prepend might just make your life a little life easier. World.prepend hello hashtag equals hello world. See also the range hashtag search documentation, the exception hashtag cause documentation, the kernel documentation, the module documentation, the string hashtag prepend documentation. 1.10 new classes problem. You want to know about some of the most useful new classes in Ruby 2.1 since Ruby 1.8. Solution: with over 9 new classes since Ruby 1.8, it can be hard to figure out which ones merit particular attention. This chapter has already covered some good ones like tracepoint, Ruby VM, and enumerator. Lazy. However, there are a few more examples of some useful classes you may not have used yet. 1.10 new classes 23. The fiber class is an interesting alternative to threads. The biggest difference is that fibers are never preempted and scheduling must be done by the programmer, not the VM. Here's what we mean. Thread equals thread.new do puts hello world and hashtag hello world. Fiber equals fiber.new do puts hello world and fiber.resume hashtag hello world. So you can see that fiber is more in your control than threads because threads run instantly. However, you can do more with fiber too. Fiber equals fiber.new do multiply fiber.yield multiply asterisk 10 fiber.yield multiply asterisk 10 underscore 0 underscore 00 done. And fiber.resume 2. Hashtag equals 20 fiber.resume 2. Hashtag equals 20 million fiber.resume 2. Hashtag equals done. Fiber.resume 2. Hashtag fiber error. Dead fiber called the encoding class shows how much Ruby has progressed in terms of character encodings since 1.8. The old hacks are gone, and UTF-8 is now standard with great and simple ways to convert strings natively built into the language. Require pp. pp encoding.list hashtag encoding. ASCII 8-bit hashtag encoding. UTF-8, hashtag encoding. US ASCII, hashtag encoding. UTF-16B, autoload, hashtag encoding. UTF-16LE, autoload, hashtag encoding. UTF-32B, autoload, hashtag encoding. UTF-32LE, autoload. String equals some string backslash U2764 hashtag. This will output a heart string that encoding hashtag equals hashtag encoding. UTF-8 string equals string.encode encoding. ISO underscore 8859 underscore 1. Hashtag encoding. Undefined conversion error. U plus 2764 from UTF-8 to ISO. 8859-1 string equals string dot force underscore encoding encoding. ISO underscore 8859 underscore 1. Hashtag equals some string backslash xe2 backslash x9d backslash xa4. String dot encoding hashtag equals hashtag encoding. ISO 8859